So for our purposes, rotating, turning a figure, here's what we're going to have to here's what we're going to have to know. Translating, reflecting, rotating, dilating. For rotations, they want you to know how to rotate 90 degrees, 180 degrees, and 270 degrees. They should tell you which direction, because you could go clockwise, which is right that way around, or counterclockwise. So they should tell you. Now, if they don't, it is assumed counterclockwise. I'll talk about that in a minute. You might say why. It's because in math, we go this direction, right? This is quadrant 1, 2, 3, and 4. Okay, so it's assumed counterclockwise. That's the rotation we go, and when you talk more about radian measure, which we will a little bit later this year, we go counterclockwise. So let's see what I got at the top first, though. There's a couple things about a rotation. First of all, they will tell you how far you're going, the number of degrees, 90, 180, 270. You also need to know where you're rotating around. So for example, here's a triangle. Most of the time you're rotating around the origin. But I could, it would be like a triangle somewhere along this path. But I could just as easily take that same triangle. I could rotate around this point over here. And now it's going more in this, right? It's going to be along that path. I could even rotate around a point on the triangle or a point inside the triangle. Okay, so you can rotate around any point. Maybe that's something that'll be a little bit new. You probably didn't do that. What I see mainly, maybe not inside. They might choose like one of the vertices to rotate around. That's a little more common. Okay, now the other thing, let's see, is so that's called the center of rotation. What you're rotating around, fixed point, which the figure is turned. And then I already talked about this one. The number of degrees you're rotating is called the angle of rotation. How far you rotate. You can go clockwise or counterclockwise. It's assumed counterclockwise, but really they should tell you. So before we move on, let's do, we're doing this for every single one so far. True or false, circle one. Take 15 seconds, think about it, and circle one. True or false? A rotation is a rigid motion. Stop. So first of all, let's review what's a rigid motion. Can somebody raise their hand? Tell me what that is.
The shape stays congruent.
Can you say it again?
The shape stays congruent.
Yeah, you do a transformation, the shape stays congruent. So now that we got that, what'd you put? True or false? Abby? True. A rotation, yes, it will remain congruent. So far, all three of them have been true. Okay, so that's a good review of rigid motion, and yes, a rotation doesn't change the size of it. I said some of this already. If no center point is named, it's assumed the origin. It's assumed counterclockwise. We're not gonna use this notation as much. Sometimes they say little r. That could be a symbol for rotation, and capital R is a symbol for reflection. I think what they're gonna do is just give it to you in words, or they're gonna use these rules down here. Okay, so let's move on. How do you rotate 90, 180, 270? There's two methods. One is, for every single one of these, there's two methods. There's a graphical one, and then there's the rules, similar to reflections. So that's just what this sums up. I will show you both. Okay. Let's start, I was thinking about going out of it. Let's start here. 90 degrees counterclockwise. So we're going back to this same thing that we did with reflections, like X, Y, arrow, and then they put the rule. So there's a rule for 90, a rule for 180, and a rule for 270. So let's look at it here on this grid before we look at the rule. So 2, 3 is the point we're going to use for all of these, just to illustrate this. The final point for G prime would be over here. So they rotated it 90 degrees counterclockwise. This point was 2, 3. The final point is negative 3, 2. So they interchanged, and the new x coordinate is negative. And it says y because they interchanged it, but that is really the x coordinate is now negative. So there's the rule, negative yx. By the way, there's going to be 3 new rules, formulas. If you like this, that's fine. You have to memorize it, though. I actually think the graphical counting method is way better on this one. Let me show you what it is. Ready? Hopefully you agree. You start at the origin, and you count to the point. I could go right to and up to, or up to and right to. Doesn't matter. I'll choose to go up to, right to. Up 3, right 2. Thank you. So I can go up 3, right 2, or right 2, up 3. Does that sound better? Sorry. So up 3, right 2. Now, here's what I do. I just think about it. Are we good that all the way around is 360? So 90 is a fourth, 180 is halfway around, 270 is 3/4 of the way around. 360 would be an entire rotation. So 90 is 1/4 of that. And I just go one axis counterclockwise. So I'm along this axis now. So up 3, right 2. I go one axis 90 degrees will be this way, and I'm looking along this axis. I'm looking this direction, and I go up 3, right 2. So you can turn your paper like up 3. You can just turn it and go up 3, right 2. Now, if it was on the computer, you couldn't do that. You'd have to look at it kind of sideways or pick up the screen. You know what I'm saying? Oh, but actually, we might do them on Chromebooks. I don't know. Actually, last year it was Chromebooks, yeah. So you might pick up the Chromebook. You could do that. Okay, so I think that's way easier because then if they're like, all right, 180, 270, you just go to a different axis. You go up 3, right 2. So let's do the rest. So all of them are 2, 3. 180 degrees. This rule, 90 was over here, 180 is down here. This one, it just changes the signs. This is actually one of the most common rules here. This is a good one to know. This one might be easier to memorize. Negative x, negative y. Just changes the signs. Let's see. Now, if you were doing the counting method, up 3, right 2, 180 is halfway around. So I say I pass over one of these axes, go to this one, and I go up 3, right 2. Again, I'm looking at it upside down. Up 3, right 2. 270 is just the negative version of 90. Again, these are all counterclockwise, so we're going this direction. 3/4. Bless you. Y negative x. 2, 3 went to 3, negative 2. So the y coordinate changes sign. Counting method. Up 3, right 2. So 270, I go, here would be 90, here would be 180, here's 270. So I go up 3, right 2. Finally, I have listed 360, but you should know 360 is a complete rotation, so you would be at the exact same spot you were. That one doesn't change. Well, I want to try two examples of this. Any thoughts, questions, concerns? Okay, number 1, let's just graph this triangle. Graph a triangle with vertices. Okay. Yeah. So let's graph the original. Trying to think. Okay. 4, 1, 2, negative 1. They didn't give it. We can label it ABC if you wanted. Rotate the triangle 90 degrees counterclockwise around the origin. All these are around the those rules, I don't know if I mentioned, are around the origin. They would not work if it was around a different point. This section for now is just around the origin, not around other points. Okay, so if you're the rule person, you say 90 degrees counterclockwise is negative yx. And so you would change the points as follows. For the first one at interchange, 6, negative 3, and then I make the first one the x-coordinate negative. 4, 1, I interchange, make this one negative. 2, negative 1, I interchange, and I make this one negative, so it would now be positive. And then you graph those 3 points. I'm going to show you on the grid. I'll do the counting method for each one. And you'll see I'll get the exact same ones. So here we go. I'm going to do this first point. Up 6, left 3. I then go to 90. I go to this axis. 90 degrees would be this one. And I go up 6, left 3. I'd be right there, and that was the same as this one. Negative 6, negative 3. I do that, I'll do different colors. I do that for this one, up 1, right 4. So then I go, that was along this axis. I go to this one, up 1, right 4. Let's check, negative 1, 4. Yep. And finally, this point right here, I'm going to go right 2, down 1. That was along this axis. 90 degrees would now be along this vertical one. What was it? Right 2, down 1. So I'm looking along this axis now, right 2, down 1. Yeah. So it's a little, because I drew in all the lines, it can be a little confusing. But without the lines here, it would be this one right there. I like the, whatever one. I like the graphical one. It doesn't require me to memorize the formula, but if you like the formula, that's fine. Thoughts on that one? We're using the same triangle, number 2. We're going to rotate clockwise this time. We're going to rotate clockwise. Now, 180 degrees clockwise. 180 degrees this way is the same as 180 degrees this way. All right, halfway around. So I can use the same rule. It doesn't matter. So I'm just going to, well here, that's what I was writing. It's equal to 180 degrees counterclockwise. This one, I think it's almost easier just to remember the formula, because all it does is change the signs. So basically, negative 3, 6 becomes 3, negative 6. 4, 1 becomes negative 4, negative 1. And 2, negative 1 becomes negative 2, positive 1. Okay, last one I'm going to do is 90. This was clockwise. But, so I haven't talked about clockwise, but you can just translate it into one of these. 90 degrees clockwise is the same as 270 counterclockwise. So actually, here, that's why I wrote this. It's actually the same as 270 degrees counterclockwise. So this rule is y negative x. Or you could do it graphically the counter way. Let's see, so y negative x. So I'm going back to these points. So if I'm doing y negative x, I interchange 6, negative 3. But I change this one's sign, so it becomes 6, 3. 4, 1, I interchange and change the second sign, 1, negative 4. 2, -1, I interchange and change the sign of the second one. 1, 2. So actually up here we've graphed, this first one in black over here was the original. This was 90, this was 180, and this was 270. So we kind of graphed all 4 of these. Okay. Well, any thoughts right now on rotations? Okay, 2 ways. Graphically or memorize those formulas. Both are good. I'll let you decide which one you want to.